Hi everybody, today we're continuing our rational expressions, rational functions graphing, and I want to talk to you today about holes and discontinuity. So basically we have this weird thing in our graph where if the graph or if the function ever factors and something cancels, then that produces a hole in the graph. So this very first example has something that factors and cancels. So I'm going to kind of talk about what a hole in discontinuity, how to find it, what it does, what it looks like. Just so you know, it is referred to as a point of discontinuity, and what it looks like is a hole in the graph. This only happens if the function can factor and cancel. So none of the problems that we've done so far have factored and canceled, which is why this is the very first one that we're talking about. Okay, so notice that I'm going to kind of zoom in here on this. Notice that my function can factor in the numerator. So it's actually x plus 3, x plus 1. And notice that the x plus 1s can cancel. So think about what that used to mean, is if it didn't cancel, there would be a vertical asymptote. I'm going to write this. Would be a VA at x equals negative 1, but it canceled. So that means that there's actually a hole at x equals negative 1. So since that vertical asymptote canceled away, that means that there is a hole at x equals negative 1. And that's just because it canceled. Okay, so my function that I'm graphing after that canceled, my simplified function, is just the line x plus 3. But there is a hole at negative 1 comma something. And how do I figure out what that something is? I take the negative 1 and I plug it in right here. Negative 1 plus 3 is 2. Okay? So here's my function that I'm graphing. It's just a line, like a y equals mx plus b, except I'm going to put a hole on my graph at negative 1 comma 2. So here's what that looks like in order to graph it. I'm not graphing the original function. There would have been a vertical asymptote there, but it canceled away. So I'm just graphing the line y equals x plus 3. That's what I'm going to graph. Hole at negative 1, 2. So this means that on negative 1 comma 2, I am going to put a hole, negative 1, 2, right here, which is just an open circle. And then I'm going to graph the line y equals x plus 3. That means you start on 3, your slope is up 1 over 1, down 1, left 1, down 1, left 1, down 1, left 1, etc. So this graph ended up just being a y equals mx plus b line, but the important part to have on your graph here is that hole. Okay, so that's all that a hole looks like. Let's continue on to the next one. I believe there's something that factors and cancels on this one as well. So I notice a bunch of GCF, some factoring that can happen. We're going to do some of that. So I can factor the top by taking out a GCF, and I can factor the denominator by doing x plus 2, x plus 3. And notice what cancels, x plus 3's. That means that I have a hole where that vertical asymptote would have been. So it would have been at negative 3. Negative 3 comma something. That's what the asymptote would have given me here if it didn't cancel. So I do need to still take that number into account, that negative 3. And when I plug in the negative 3 into this x and this x, my new function, after I canceled everything, is just 3x on top and x plus 2 on the bottom. So this is different from the first example we did where it was just a line that was left over. In this case, we still have a rational function left over with the asymptotes and stuff. But what I'm doing is plugging in this negative 3 here and here to get this y value. So when I do that, I end up with negative 9 on top, and negative 3 plus 2 is negative 1 on the bottom. That just gives me positive 9. So I have a hole on my graph at negative 3 comma 9. And then everything else that I'm going to do, I can actually put that in my chart down here, negative 3 comma 9. And I can put it on the graph too, negative 3 comma 9, 3, 4, 5, 6, 7, 8, 9, right there. So now we're going to go through all of the same stuff that we've been doing on previous examples. Vertical asymptote comes from setting the denominator equal to 0, and that means that I have x equals negative 2 as an asymptote. Horizontal asymptote, the degree of the numerator is the exact same as the degree of the denominator, so my horizontal asymptote is y equals the lead coefficient over the lead coefficient, which is just 3. And then y-intercept, that means plug in 0 for x. So 0 comma something. When I plug in that 0, I get 0 on top, 2 on the bottom, equals 0. That's my y-intercept. My x-intercept comes from setting the numerator equal to 0. So 0 equals 3x. And that's by plugging in 0 for y or setting the numerator equal to 0. When I solve that, I again get x equals 0. So 0, 0 is both my x-intercept and my y-intercept, and I have a hole here. So I just had to put all this together and see what it looks like. I'm going to start by doing my asymptotes. I have one of them at -2 on the x-axis. So here is -2. And my horizontal asymptote is at y equals 3. That is right here. And I have an x-intercept and a y-intercept. Those are both 0, 0, so I can put this point here. And I have the hole that I can use for part of my graph. So it's not just a random hole. The hole has to be on part of the graph. So I know that it's going to attract, the asymptotes are going to be attracted to the graph. So there's that part of the graph, and since I have an x-intercept and a y-intercept on this part, I know that the other half looks like this. So remember, those dogs run right up to the fence, but they don't go through it. And just notice that we have this hole on this graph. That is very important. That is pretty much the whole point of doing this example here. So make sure you don't overlook the fact that you need to have a hole on your graph. Okay, let's talk about how to tell if the function crosses the horizontal asymptote. This is the second part of this section. I'm going to fill in something you need to get copied down. You can pause the video, and then we'll do example number 7. Alright guys, so here we are. Go ahead and copy down what I have written here for how to tell if the function crosses the horizontal asymptote. Sometimes, you guys, I don't know if you've ever seen this, my mom's dogs go through their fence. And yes, they like shake their heads because they get a little bit of a shock on their neck from their collar, but it does happen. Sometimes they get through the fence, and sometimes our graph will go through the horizontal asymptote, and there's a test you can do in order to tell if this happens. So here's what you do. You set the function, so the original equation, equal to the horizontal asymptote, whatever number you have down here. And then you just cross multiply to try and solve. Sometimes you can solve that equation. If you can solve it, it crosses at that x value, whatever you get, like x equals 3 or x equals 0. And then sometimes you can't solve the equation, like no solution. That means it doesn't cross. Let's take a look at this example. I know that this function factors in the denominator. So that means I have x on top, and I have x minus 3, x plus 2. So that means that I have two different vertical asymptotes, one of which is 3, and one of which is -2. My horizontal asymptote, the degree of the numerator is less than the degree of the denominator, and by definition I have memorized that that means that y equals 0 is my horizontal asymptote. Okay, y-intercept and x-intercept. So y-intercept, that just means plug in 0 for x, and I get 0 comma something. I'm going to show my work out to the side. So when I plug in 0 for x, I get 0 over 0 minus 6. 0 divided by anything is 0. X-intercept, that means plug in 0 for y, or set the numerator equal to 0, which means x equals 0. That means my x value here is 0. So again, 0, 0 is my x-intercept and my y-intercept. A hole, let's see, did anything factor and cancel up here? No, nothing factored. That means that there is no hole. It did factor, but nothing canceled. That means we don't have a hole. Here's how to tell if it crosses the horizontal asymptote. What I'm going to do is set my equation, which I factored up here, equal to the horizontal asymptote. So here's my test for that. I'm going to do that down here in blue. So I have x over x minus 3, x plus 2. This is my equation, and I'm setting it equal to the horizontal asymptote, which is 0. And when I cross multiply, I'm going to put the 0 over 1, cross this way, and I get x. Cross this way, anything times 0 is 0. that means that it crosses at x equals 0. And when I plug in 0 to my equation, 0 comma something, I just plug it into the normal equation, the equation that I have written at the top. I also have it written right here, 0 divided by 0, 0, plug 0 in everywhere. I get 0. That means it crosses at 0 comma 0. That means it goes through the fence at 0, 0. Okay, so let's put all of this together on our graph. Let's see, I have two different vertical asymptotes. I have one at -2, which is here. I have one at 3, which is here. And I have y equals 0 as my horizontal asymptote. And I have an x-intercept and a y-intercept at 0, 0, which is weird. Okay, so I actually don't have very much information about what this graph looks like. I need to know what's happening in this section. Is it up here or is it down here? I need to know what's happening over here. Is it up here? Is it down here? And the fact that it goes through the fence here means that my graph could look like this, like a snake. It also could look like this kind of a snake. So I actually need a lot of values in my t-chart to figure out what this graph is going to look like. So what I'm going to do is make a t-chart down here, and I'm just going to pick an x value that is on this category. So I'm going to pick like -3. And I need multiple values in here. I'm going to choose -1. I know what happens at 0. I'm also going to choose +1. So I'm going to do -1. I already know 0, so I'm going to do +1. And I also need a value over here in this category. So I need categories of each section divided by all the asymptotes. So I have 3 different sections here that I need to test. So I'm going to test x equals 4 here. You can just use a calculator to plug in these values, and I'm just going to show you what we get. So at -3 I get 1/2. At -1 I get 1/4. At +1 I get -0.16. These are all weird values because I mean, like, look at the equation we're plugging into. At 4 I get 2/3. So I just have more values. I just made a t-chart and I picked some x values to try and help me. Remember, the more x values you choose, the more points you have on your graph, the more accurate your graph is going to be. So let's start with -3 comma 1/2. That is right here. That tells me that this section of the graph looks like this. Remember, it always runs right up towards the asymptote, but doesn't go through it unless we have just learned that it actually can cross right here. Okay, let's do the next point in the t-chart, the -1 comma 1/4. -1 1/4 is right here. Okay, that tells me that it comes down, goes through that point, goes to 0. Let's do the next point, 1 comma -0.16. So that is just underneath right here, which tells me that it goes through and then again runs right up towards the asymptote like that. So this is why I needed all of these values to figure out what my graph looked like. My last point is 4 comma 2/3. So at 4 I am here. And that's the last section of my graph. Okay, so that is a really weird looking graph, and they're going to get more and more strange. So let me tell you one more thing about crossing the horizontal asymptote. Remember how we wrote down up here that if you can solve it, which we did, we solved it down here and we got x equals 0, it crosses at that x value. So what does it look like if you can't solve? What do I mean by that? Let's go back up to this example. Let's just do the test just to see if it crosses, so I can emphasize what it looks like. You know that for this one we didn't even check it because we didn't know what it was. Notice how it does not cross the horizontal asymptote, but I didn't even check it. So what does it look like if you can't solve it? So remember what you're supposed to do to check to see if it crosses. You set the equation, and notice how something canceled, so you always use the simplified one. So the equation is 3x over x plus 2, and you're supposed to set it equal to the horizontal asymptote, which in this case is 3. I'm going to put the 3 over 1, and I'm going to cross multiply. This means that 3x equals, when I cross this way and distribute the 3, I get 3x plus 2. 3x's cancel on each side, and I get 0 equals 2. that means no solution. That means it does not cross. So that's what it's going to look like, you guys. If I give you one and I say, does it cross, and you can't solve it, that means it doesn't cross. Okay, this one we actually could solve that equation down here, and we ended up with a value for x. It wasn't a no solution, it was an actual solvable equation. That's why it crossed right here. Okay? Two pretty crazy looking examples right there. So bring your questions to class tomorrow, and we will continue talking about these functions. Have a good night.